Alright, today we're going to talk about implicit differentiation. Who can spell differentiation, really? Let's just call it implicit diff. Alright, so we're going to use, well, what does this actually mean? Okay, so let's do it through an example. X squared plus y squared equals 9. Okay, and we want to find a derivative, dy dx. Okay, well, what is this? This is a circle. It's of radius 3. Okay, now we could rearrange this for y, okay, but we're going to do it a different way. Okay, rearrange it for y, take a derivative the old-fashioned way, and that's great. Okay, but what we're actually going to do is do something a little different. Because basically what we're saying, this y, this implicit bit, what it means is this y is a function of x. Right? We could rearrange this for y, for x. In terms of y in terms of x, okay, and do it that way. But we're saying this y, hidden behind it, a bunch of x's, some function of x here, okay? Sometimes, when we've got relations, we cannot rearrange them to get y as the subject on its own. So this is where the implicit differentiation really comes in handy. This time we can, but it's a good one to do an example. Okay, so how do we do this? We want to take a derivative of each of these bits. Now, the simple way to do this process without explaining too much is you just take the derivative of each bit individually. So the derivative of the x squared bit, because I want to do this in terms of x. I want dy dx. So I want to differentiate with respect to x each of these bits. Okay? So to differentiate this bit with respect to x, that's easy. We do it all the time. 2x. Yeah, just bring the 2 down, take 1 away from the power, you get that. Now, how do you differentiate when you've got a function in terms of y when you know this is a function of x? So how do you differentiate this with respect to x? Okay, the key is to do with the chain rule. All right, so what we do is we differentiate it with respect to y first, and then multiply it by dy dx. Okay, because this is with respect to y, and that dy would cancel out with this dy, and you'd have a derivative. Now we've got the derivative of this with respect to x. Okay, just by multiplying it by dy dx. Okay, what's the derivative of 9 with respect to x? 0. Okay, and that's it. We can rearrange this for dy dx now, make dy dx a subject, so I get 2y dy dx equals negative 2x, move the 2x across, divided by 2y, dy dx equals, well, the 2's will cancel out, so we get negative x on y, and that's it. This is dy dx in terms of x and y. That's implicit differentiation. Basically, when you've got a y, you just differentiate with respect to y and times by dy dx. That's it. That's the whole thing. It's the whole premise of the story. Okay, let's see if this is even right. Yeah, let's do it the old-fashioned way. So let's go y equals plus minus the square root of, what have we got? 9 minus x squared. Okay, let's just do the positive function for the moment. Right, we can take the negative of it later on, because it's just going to be multiplying by a negative. Okay, so let's just take the positive. So we'll get rid of that. So dy dx equals, okay, what do we got? We've got half times negative 2x on the inside of the bracket times 9 minus x squared to the negative half. Okay, so that 2 will cancel with that 2. I'm left with negative x 9 x squared to the negative half. Let's move that to the denominator. So I get negative x, this bit, equals the square root of 9 minus x squared. Okay, now, this looks different to this. Is it the same or not the same? Hang on. This is negative x on y, and y is equal to the square root of 9 minus x squared. This is the same as this. Wonderful. It works. It's an amazing thing. Let's try another one. Let's try a different one. Okay, rub this out. This is a beautiful and wonderful thing, this implicit differentiation. Okay, so what do we get? We've got 4x squared. Yeah, that's working, sorry. 4x squared plus xy plus 7 equals 0. Okay, we're going to try the same process again. We take the derivative of each one individually with respect to x. Okay, so the derivative of this one with respect to x, just 8x. That's easy. This one plus with respect to x. Now we've got a product of two functions. So we've got this x times y, and y, you know, it's a function of x. We can't see it behind the y, so we need to do the product rule here, but we just do implicit product rule, so we just do it the same way. So we'll take the derivative of x first, times it by y, so the derivative of x is just 1, so I get 1y. And then the derivative of y, we add on, times it by x. So the derivative of y is just 1 times dy dx. So I get dy dx times x. Okay, that's that. The derivative of 7, that's just 0, equals 0. Derivative of 0 is 0. And we can rearrange this now to get dy dx on its own. So we go y plus x dy dx. I just write that the other way. Equals negative 8x. We can minus the y. X equals dy dx. Negative 8x minus y. Divide the whole thing by x. Dy dx equals negative 8 minus y on x. And that's it. It's pretty cool. We've got dy dx for this relation here. This relation here, dy dx. It's a great thing. Alright. Should we do something a little different? Let's try, see what happens when we do this one. Let's do e to the 2x y squared equals c. Okay, so we're going to try and find dy dx here. Okay, so implicitly differentiate. So what are we going to do? We're going to, well, e, right? We just, to take the derivative of e with respect to x, we just get the same thing. e2xy squared. And then we multiply by the derivative of whatever this power is. Now, we're going to have to use our good old-fashioned product rule again. So we'll go 2x, that function, multiplied by the derivative of this, times 2y dy dx, right? That's with respect to x, plus, the other way around, y squared times 2, okay, equals derivative of c, that's a constant, so we get 0. Alright, what have we got here? Let's try and work this out a bit better. Hopefully I haven't made a mistake. What have I got? I've got 4xy dy dx plus 2y squared. Okay, just simplifying it up a bit. Can I rearrange this now for dy dx? Okay, so I divide both sides by e to that goes, it's gone. Minus, well, I can get rid of, I can divide it all by 2. Let's divide by 2, so that's gone. This is changed to a 2. Running out of space, this makes it a bit easier. So I get, I can divide both by y, gets rid of that one. So now I've just got negative y on 2x, that's easy, dy dx, negative y on 2x, wonderful. Okay, what else do we need to talk about? We need to talk, we're going to do a quick parametric equation one. Let's do one with parametric equations. Okay. So if we've got our parametric equations for x and y, let's go with 2 cos t and y equals 5 sine t. Okay. Now, we want dy dx, but we've got all these x's and stuff in terms of t. So we could get dy dt easy enough. So what dy dt times what is going to give me dy dx? Okay, so I want, I can get dx dt, but I really want dt dx, don't I? So dt dx, right, I could try and rearrange this and do it that way, but or we could just take the reciprocal of dx dt. So dy dt times 1 on dx dt will give me dy dx. Okay, so let's do that really quick. Okay, dy dt, the derivative of this is 5 cos of t, the derivative of dx dt, that's negative 2 sine of t. Okay, and now we want to flip this up, so dt dx is, well, it's just 1 on negative 2 sine t. Okay, so we multiply these two things together, we get dy dx equals 5 cos of t on negative 2 sine of t, and we could write that as cot if we wanted to, 5 negative 5 cot of t. Okay, we could change these to x and y's here though, couldn't we? Because we've got, if we wanted to change these to x and y's, I wonder if this would work. We could, we've got this in terms of t, but we might want dy dx in terms of that. Let's just try this out. Not really sure what's going to happen. Alright, so we know cos of t is the same as x on 2, and we know sine of t is the same as y on 5. So if we substitute these in for the cos and the sine, what do we get? Dy dx equals 5 times x on 2, 5 times x on 2, over negative 2 times y on 5. Okay, what do we get now? We get, well, that 5 is going to come up to the top, so we're going to get 25x. We'll make the whole thing negative. 25x on 4y. That's pretty cool. So now we've got the derivative in terms of x and y. We've eliminated the t's there. Okay. That's all we're going to do. I don't think I can do any more right now. Okay. Alright. That's it. Well done.